Hello everyone, let's solve Max exam Math B 2014, okay, question 1.5. So this is a question of number theory, okay, number theory. So what is he asking you? He's asking you, you have this number over here, you have 600, and he wants to know the number of divisors and the sum of the divisors, okay, sum of divisors. So these are the two things he wants. So how do you go on solving this? Well, 600 is very big, so let's take an example. What if he asked you the number of divisors of 12, for example, or maybe even smaller, okay, or maybe 18. Let's do 12 and then 18, okay. So 12 would be, you can divide it by 2, so you'll have 6. You can divide by 2, you'll have 3. You can divide by 2, you'll have 1. So 12 is 2 to the second multiplied by 3, right? Now, the divisors of 12 are what? The divisors of 12 are 1, 2, 3, 4, 6, and 12. So easy, right? You have 1, 2, 3, 4, 5, 6. So divisors are equal to 6. Their sum, well, the sum is 12 plus 6 plus 2 is 20, 28. So the sum is equal to 28. But this is not our objective. We don't gain anything by doing this way. What we are trying to use this example for is to find a general rule so that we can calculate for 600, right? So when we did the when we factored 12, we found that it is equal to 2 to the second multiplied by 3, right? What does this mean? Well, it means, look, 2 to the second, it can be, so we can have this variation, 2 to the 0, 2 to the 1. 1 second, let me put spaces. 2 to the 1 and 2 to the 2. 3 to the, because after this it's bigger, so it's not counting. And 3, we can have 3 to the 0 and 3 to the 1. So what combinations can we do? Look, we can multiply this by this and by this. So what can we have? In the first one, we'll have 2 multiplied by this, it will be 1, right? 2 to the 0 is 1, multiplied by 3 to the 0 is 1. The second is 2 to the 0 multiplied by 3 to the 1, so it is 3, okay? Now we can do this multiplied by this and multiplied by this. So 2 to the 1 multiplied by 3 to the 0, we will have 2. 2 to the 1 multiplied by 3 to the 1, we will have 6. Now we can do this and this, right? So 2 to the second power multiplied by 3 is 4, and 2 to the second power multiplied by 3 to the 1 is 12, right? 2 to the second is 4 multiplied by 3 is 12. So look, these number over here are these numbers over here, right? So by choosing the way these numbers can be multiplied all together, we ended up finding the divisors, right? The divisors. So what we are going to do now is to try to use them as a way. So look, what did we basically do? We had 1, 2, 3 numbers. 3, 1 second. We had 3 numbers over here, and here we had two numbers over here, and this is equal to 6, and this is not any magic or anything like this. This is really what we are doing over here. This is the number of divisors, because if we have these three numbers over here that we are multiplying by, it's like doing combinatorics, right? You can choose three numbers over here, and here you can choose two numbers, right? So this is what we are doing. So look, in the case of 12, what was what? It was 2 to the second multiplied by 3 to the first, right? So what did we do? The number of divisors was equal to what? 2, this exponent, 2 plus what? Plus 1. Why plus 1? Why plus 1? Why plus 1? Because we have 2 to the 0. We have 2 to the 0, 2 to the 1, and 2 to the 2. So this exponent was 2 over here. But we don't want just 2 exponent. There is the 0 also, right? So we need to count for it. So we take the exponent and plus 1. And now we multiply it for this exponent is 1 plus 1. Why? Because again, 3 can be 3 to the 0 and 3 to the 1. So you need to consider this possibility of this 1 over here and this 0 over here, okay? So the number of divisors is equal to 3 multiplied by 2, which is 6. Now what about a number? Let's say that we have a number over here, okay? An imaginary number over here. Number, okay? That is equal to, let's say, 2 to the A multiplied by 3 to the B multiplied by 5 to the C, and these bases over here must always be the prime numbers, okay? Maybe multiplied by 7 to the D. You can go ahead and choose it, okay? So the number of divisors, the rule for the number of divisors, it would be A plus 1 multiplied by B plus 1 multiplied by C plus 1, and there goes forever, okay? So this is our rule basically, okay? So let's test it for 18, okay? 18. So the first thing we found, we do this factorization to find the primes, okay? The primes number. So 18 divided by 2 is 9, divided by 3 is 3, divided by 3 is 1, okay? So 18 can be written as what? As 2 multiplied by 3 to the second, okay? So the number of divisors, if we would use this rule over here, we would use that A plus 1, well, 1 plus 1, right? Because this is 1. This is 1, and this is this one. And then multiplied by 2 plus 1. This 2 over here, okay? So numbers of divisors would be equal to 2 multiplied by, wait, did I forget something? 18 divided by 2 is 9, 3 to the second. Yeah, so it would be 2 to the multiplied by 3, so it would be 6 2. So let's test it. 18, so the divisor, it can be 1, it can be 2, it can be 3, it can't be 4, it can't be 5, it can be 6, it can't be 8, it can be 9, it can be 9, so, and it can be 18, right? So we have 1 2 3 4 5 6. So check. Now again, why is this working? Because 18 is what? Is 2 multiplied by 3 to the second power, right? So 3 to the second power. So you can represent all his divisors by 2 to the 0 and 2 to the 1 multiplied by 3 to the 0, multiplied by 3 to the 1, multiplied by 3 to the second. And by doing the combinatorics between these multiplications, you find all the divisors by doing 2 multiplied by 3, 2 multiplied by this, as I did in the first example. So you have like this place you can choose 2, and this place you can choose 3, so it is 6. Okay, and why are we summing this one over here? Why are we summing this one over here? Because we are counting the possibility of 3 to the 0 power. Okay, so now we can solve our first part of the question. Okay, so what did we have? We have 600, right? So 600, so divided by 2, 300, divided by 2, 115, divided by 2, 75, divided by 3, 25. Let me just divided by 5, 5 divided by 5, 1. So we can write 600 is equal to what? 2 to the third power multiplied by 3 multiplied by 5 to the second power. Okay, we have 2 5s, we have only 1 3, and we have 2 2s. Okay, so this is what we are doing over here. It was yellow, right? Yes. So this is the how we represent. Now, how was our rule? Like, we can use, look, we can say that it can be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and this can be 3 to the 0, 3 to the 1. Yeah, it's just 3 to the 1 because it's not 3 squared. And this can be 5 to the 0, 5 to the 1, 5 to the 2. Okay, so how slots do we have? Well, we have 1, 2, 3, 4. We have 4 slots for this one, 2 for this one, and 3 for that one. So we have 12 multiplied by 2, 24. Okay, so 24. What I did here was just so this one was the yellow one, and this one was the green one, and this one was the red one. Okay, so this is a way for us to represent it. And if you wanted to use the formula, like if you was already good with this, you could have said, so the divisors are what? Well, we have 3 here, so 3 plus 1 multiplied by 1 plus 1 multiplied by 2 plus 1. Okay, and this will be 4, 2, 3, which is 24. So now for the second question, the whole sum of those divisors. So let me just pause the video and clear this thing over here to solve the second part. So for the number of the sum of those divisors, let's do the same thing that we did to find the number of the divisors. What did we do? We used 12 and 18 as an example, and we found a rule and like to make sense of it, and then we used it for 600, right? So let's try to do the same. And here I just wrote it all beautiful again. So 600, this is how we did the factorization. You are probably watching this video in the same time, right? So this is 600 with its factorization. So 4, it is 3 plus 1, 2, it is 1 plus 1, and this 3 is 2 plus 1. Okay, and this multiplication is 24. So I think the number of divisors made sense. So now let's find the sum. So look, I'm going to leave this space over here, this all this space over here. Okay, so we are going to find a rule for it down here by using the 12 and 18, and then we are going up here and use this rule to solve our question. Okay, so look, 12, what was it? 2, 6, 2, 3, 3, 1. Okay, so 12 was 2 to the second multiplied by 3, and those numbers, the number of the divides were 1, 2, 3, 6, I forgot 4, right? 4, 6, and 12. We have 6 divisors, which are all the combination of 2 to the 0, 2 to the 1, 2 to the second, 3 to the 0, and 3 to the 1, right? Because all we need to do is 2 to the 0 multiplied by 3 to the 0 is 1. 2 to the 0 multiplied by 3 to the 1 is 3. 2 to the 1 multiplied by 3 to the 0 is 2. 2 to the 1 multiplied by 3 to the 1 is 6. So let's use this blue over here. So 2 to the second multiplied by 2 is 4. And let's see if we have one more color. This one is not good. Let's go with this one. So 2 to the second multiplied by 3 is 12. So look, if you can, for this example 12, we can go and just, one second, let me find the white color. Where is the white color? There, here we go. So you can sum 4 plus 12 plus 6 plus 2 plus 3 plus 1, right? What this was 12 plus 6 plus 2 is 20, plus 8, 28, right? So this sum is 28. But how else can we do this? Well, it is really the sum of these multiplications, right? So it is 2 to the 0 multiplied by 3 to the 0, which was 1, and plus 2 to the 0 multiplied by 3 to the 1, which was 3, right? I'm just summing them before I multiply them, okay? So plus what? Let me just, here we go. Plus what? 2 to the 1 multiplied by 3 to the 0, okay? Plus 2 to the 1 multiplied by 3 to the 1, okay? So, one second. Here we go. So, and then we have plus the last one, plus, so we have plus 2 to the second multiplied by 3 to the 0 plus 2 to the second multiplied by 3 to the 1, right? So let me try to do this. Over here. I know it's small, but let's put few colors just so 2 to the 0 multiplied by 3 to the 1, so this one was the red one, and then we had a yellow one. So 3 to the 0 multiplied by 3 to the 0 is this one, and then we had a green one, which is 2 to the 1 multiplied by 3 to the 0. So 2 to the 1 multiplied by 3 to the 0. And then what color did we have? This purple one. 2 to the 1 multiplied by 3 to the 1. and then we had a blue one, right? So this blue over here, 2 to the second multiplied by 3 to the 0, 2 to the second multiplied by 3 to the 0, and let me see if I can find this last color over here. Here. So these are our possibilities. Now look. Here we have 2 to the 0 multiplied by 3 to the 0 and 2 to the 0 multiplied by 3 to the 1, okay? So I'm going to take 2 to the 0 outside in evidence. So it would be 2 to the 0 multiplied by 3 to the 0 plus 3 to the 1, right? It is the same. If you multiply 2 to the 0 multiplied by 3 to the 0, you will go back to this. If you multiply 2 to the 0 multiplied by 3 to the 1, you will go back to this, okay? So I didn't do anything fancy over here. So plus, now 2 to the 1, I'm going to do the same thing over here, okay? So 2 to the 1 is multiplied to 3 to the 0 plus 3 to the 1, okay? Notice, if you multiply this here, you will get this back, okay? So plus, now let's do the same thing that we did before, just to make it smaller, okay? So plus, now I'm going to do it over here. 2 to the second multiplied by what? 3 to the 0 plus 3 to the 1, right? If you multiply it again, you'll go back over here. So why did I change this? Because now look, notice, we have over here 3 to the 0 plus 3 to the 1, 3 to the 0 plus 3 to the 1, 3 to the 0 plus 3 to the 1. So how can we represent this? Well, we can represent it like this: 2 to the 0 plus 2 to the 1 plus 2 to the second multiplied by 3 to the 0 plus 3 to the 1. Why can we do this? Because I did the same thing that I did in this step over here. In this step, I was taking the 2's in evidence, right? In this step, I took the whole parenthesis of the 3 to the 0 plus 3 to the 1, okay? So what essentially I did in this step over here that I'm taking out now, I will do it again. So look, we are going to take in from outside this parenthesis the 3 to the 0 plus 3 to the 1. So what are we going to have left? Well, I took out the 3 to the 0 plus 3 to the 1, so we are having 2 to the 0 plus 2 to the 1 plus 2 to the second, right? Because if you multiply this over here, over here, over here, you will get this back, okay? So, and this is the rule that we wanted, because look, this is 12, and 12 is what? It was 2 to the second multiplied by 3, right? And look what we ended up having. We ended up having 2 to the 0 plus 2 to the 1 plus 2 to the second multiplied by 3 to the 0 plus 3 to the 1. You see, it is all the possibility of the exponents. Now I wanted to do it with 18 too, just to make, for you to get more familiarized, but it is already a long video. I think it's 20 minutes already, so try to do it by yourself for this 18. So the rule that we found, now I know this is not a mathematical proof, but I think I gave you a sense why it works. So the sum of divisors that we found was, let's write the rule here first. So look, if we had a number, okay, a number which we can write like 2 to the a multiplied by 3 to the b multiplied by c multiplied by 5 to the c, thing like that. So we are going to have, the rule is 2 to the 0 plus 2 to the 1 plus 2 to the 2, and there goes until 2 to the a, okay, just as in here. And for b, the same thing, 3 to the 0, 3 to the, and there goes forward, okay. So this is the rule that we are going to use over here. So look, what we are going to have, the sum is, let us just write it a bit down just here. The sum of D is equal to, well, we have it until 2 to the 3, so we can have 2 to the 0 plus 2 to the 1 plus 2 to the second plus 2 to the 3, right? So we can have this. And then for the 3, what can we have? Well, for the 3, we can go 3 to the 0 plus 3, and then we can have the 5, right? So the 5 is the one that going the largest, right? So here we go. So for the 5, we have 5 to the 0, 5 goes to 3 to 2, easier. So plus, and here it's not summing, it's a multiplication. So 5 to the 0 plus 5 to the 1 plus 5 to the 2. Okay, so now if this was bigger, you can notice that these are geometric progressions, but it's not that big, so we can just solve it. Okay, so 5 to the second is 25 plus 5 plus 1 multiplied by 3 plus 1, and so, and multiplied by 2 to the 0 is 1 plus 2 plus 4 plus 8. This 8 is 3 cubed, okay? So how is this? So 8 plus 2 is 10, so 15 over here. 15 multiplied by 4, 3 plus 1, multiplied by 31, right? 31. So I'm going to pause this video. I won't do this multiplication now. Just 1 second. The answer we get is 1860. I paused the video because this multiplication, it would take me time. So, and the video is very long already, okay? So this is the answer. Try to do it by yourself after a while to deduce it by using this 12 over here to find the pattern, so that you be more familiarized with the formula. Okay, so this is it.